Let's start class.
Maybe. Who knows?
All right.
We're gonna find out.
I don't know if that's a strong enough clap, so I didn't know. All right.
We need your book.
That'll be real helpful.
All right. Same.
So let's go over, what was it, 6.4 that you had for today. Can we turn off maybe the lights that are by these projectors so it's a little bit
Bryson, would you turn the lights off by the projectors, please? Thank you. Oh, come on.
All right. So, unfortunately, I don't have easy access to my campus drive, so I didn't write this up ahead of time. So help me out in filling in the data. I'll go quickly here. If you guys read it through, there's 15 variables. Okay, so
15 variables.
all right. What are the sources of, what is it, computers that we're shipping here? Or? Yeah. So give me the different places here. Down. Seattle. Los Angeles.
Do you have the picture? Yeah.
What?
Then how do we have a different?
That okay.
Where's that fish?
Okay. What's next?
New York. What?
6.4.
And yeah. Okay.
What problem is this?
I think it's 6.4.
We did 6.4. We had a totally different problem.
Yeah.
Ours is about
what did you?
Yeah.
In Texas.
What?
In Michigan and Texas.
What edition are you using?
You know what edition
was?
is? I thought it didn't.
I don't know. I just got on.
I
can
use
tell you
the
on
online
Amazon.
edition.
Did they actually start to change the problems?
Maybe just ours is about
Wait,
fish.
I can look up.
Glowing fish. Pretty sweet.
That must. Was it still a transportation problem?
It was a shipping problem.
Yeah,
So you had to like
kinda.
minimize the shipping costs.
I guess it means you need to start looking and seeing if they match the physical version, because that's what I have planned for to make sure that.
Well, we
Well,
used
no,
the
no.
physical
I use
version.
the physical.
Yeah, we used like a textbook.
Huh. So that's like 13th edition then, or?
I can look up my Amazon order and find it.
Okay, well I'll need to be careful then, going forward then. Because this is the first time this has happened, right?
Yeah, I think so.
I think so.
Yeah.
And the physical for 15, it's glowfish as well.
No, it's not my wallet. I don't go there.
That's the 15th.
15th?
Yeah.
We didn't use the 15th.
I don't know what
Wow,
online.
okay, so they must have just changed it. Wonderful. All right. So that means we'll be careful here.
Can we do?
All right. So those of you who use older editions of the textbook, help me out then. Where are we shipping these from? Shipping them to?
Pittsburgh. Top of my list.
Pittsburgh.
Mobile.
What did you say?
Denver. Los Angeles.
I don't even know. I didn't know what they did. Just because they're like Salesforce. They're like the #1 CRM.
Right?
They used it also.
All right. And what are the... Wait, did I misspelled Los Angeles, didn't I agree. All right, so what are the values here going across?
I'm driving my guy.
0. So let's label it. That's a good idea. What are we talking about? So this could either be the costs. So why don't I
I didn't
copy
bring
this?
anything.
Put this down here. Or it could be how
I
much
came
we
from
ship.
CVS.
Right? So let's make this
Oh, I came from CVS. I
the
don't have it.
number shipped.
I brought hot tamales.
And I'm going to make that bold and maybe a little bit bigger, so it's really easy.
said yes, and then like an hour later it was like,
And let's make this be the cost.
don't need you because we have management. So then I asked her again, she had
Katie suggested someone.
All right, so what were the costs to ship from each of these, from Seattle to Pittsburgh? 10?
20.
Oh, number.
5.
Because we got
Hashtag accommodate 2018.
I'm on board. We're just ahead of game.
120.
Yeah, we are. If they can take a point, I'm gonna be so mad.
4? All right. And then we need to be able to, right here, this is going to be, what does this represent? This represents amount available, right? And shipped. And if we go like this is going to represent amount demand and receipt. I'll make that, so I don't say shipped in both of them. It'll make it a little bit easier to distinguish between which side we're on, right? So how much do we have available in Seattle?
9,000.
How about in Columbus?
4,000.
And New York?
8,000.
And how much do we want in Pittsburgh?
3,000. 5,000. 4,000. 6,000.
Also, my Excel still doesn't work, and I don't know why.
All right. So now we've got all our data. I'm sorry it took a little bit of time to get that in. Now what we need to do is we need to set up our constraints, right? So what is one type of constraint that we want to have, or one class of constraint that we want to have in this system? Help me out while I set this up.
The number of ships has to equal demand.
The number shipped has
Did
to
you
equal
convince them to do the
demand.
other project?
So you want a demand constraint. So the number received is, yeah, okay. So how much, how do we know how much Pittsburgh has received? It's those ones, right? And we can copy those. And what you're saying, Bryson, is for that constraint, we want to say that our demand is equal to what we receive. All right? What's another type of constraint that we want to put in here?
Well, we can do the same thing with available and shipped.
Okay, so how do we know how much Seattle has shipped?
It would equal the sum of all the rows.
All right. And again, we can copy that. And so what you're saying, Jessica, is that a second type of constraint is that what we have available, well, let's change that to what we ship, is equal to what we have available. All right. Are there any other constraints? Okay, so let's go through our model then. Our objective, we need to figure out what our objective is. In English, what is our objective? Okay, so total costs. And how do we compute those total costs? Some product of what?
The variables and the costs.
Okay. How much we actually ship with the cost per unit shipment, right? So if we go back and set our objective to this, you said we want to minimize that cost, right? We don't want to pay for shipping. None of us do for anything, right? And then variables. What are the variables? It's how much we ship from any location to any other location. All right. So $150,000 to do our shipping there. Hopefully that was pretty straightforward for you based on what we talked about on Wednesday's class. But there was an interesting twist at the end of this question, I thought, right? What was it part C, or what was the change that they asked you to evaluate?
Increase
The Pittsburgh demand from 3,000
4,000.
to 4,000. And to accommodate that, we have to make more units. And where are we going to make them? By that same 5,000, right? So if we go ahead and solve it, now I'm just going to go here and copy that value, and I'm going to paste just the value, right? And if we solve this, I think this is really interesting, right? The fact that we increase the amount of units that we ship by 1,000. Normally you would think that that would increase costs because we're shipping more stuff. Why does this make sense that we actually increase the amount that we ship and we get lower costs? What happened? How come we were able to do that? Why were we able to lower costs even though we increased product shipments?
Columbus was able to fully satisfy the demand at Mobile,
Mm-hmm.
which freed up more for like cheaper routes.
Right. So by having that dedicated Columbus to Mobile route, that we didn't have to go take the Seattle or the New York routes in there. And so by doing that, we were able to send more on that cheap route. All right. So that's a really interesting thing to think about. All right. So hopefully there weren't very many tricks in this assignment. Hopefully it was pretty straightforward. Let's continue thinking about these kinds of transportation problems. So let's turn the lights back on.
We could do the glowfish one.
Which one is that?
Can we do the glowfish? Can we do the glowfish one? It's a transportation problem. So.
Offline I can. Hopefully it was the same kind of thing.
Yeah, it was pretty close.
Okay.
All
All right. So if you remember from your notes on Wednesday, we had Kansas City, we had Omaha, and we had Des Moines. We had Chicago, we had St. Louis, and we had Cincinnati. And we had routes between all of these places. And that is our transportation system. So I'm going to just put the costs on here real quick. But I'm going to change 4, 5, and 12. So this should look very similar. I will keep the demand at our final locations, these manufacturing plants, as 200, 100, and 300 here. But what we're going to add to our system now is another layer. So we said that these could be like grain elevators or something like that. So let's put in the farmers themselves. These will be big farms here. So we'll have 2 farms here, one in Nebraska and one in Colorado. All right, and again, they can go to any of these facilities to store their grain. All right. So now, these are true distribution warehouses. If you remember going to the Walmart Distribution Center, maybe for Systems 101, right? These operate just like that, where in comes product from vendors, from different locations, and out goes that same product to the different Walmart stores. Right? This is going to operate the same way. So ideally, we don't want to keep any of that product here, right? This is just a temporary storage location that we're maybe changing semi-tractor trailers that this stuff goes on, combining the different pieces of merchandise together to get it to the right final retail center, okay? So unlike before, we're not going to have a supply at these locations right here. Ideally, we don't want anything here. The supply is going to come, in this scenario, from our farmers, okay? And so we need to add new costs for these new routes right here. So let me do that. From Nebraska to Kansas City, it's 16. To Omaha, it's 10. And to Des Moines, it's 12. Colorado, it's 15. 14. And 17 right there. And I didn't write my supply. I hope I have that on the next page. This is going to be interesting. All right. We will do this then. We'll just have equal supply at each location. So we'll generate 300 at each of these. Okay. Okay. So now we've got multiple layers in here, and we call this kind of a problem a transshipment problem rather than a transportation problem, because we're going through some destinations and we're ending at other destinations. So we need to change up our nomenclature here a little bit. So I'm going to do the same thing I did before. I'm going to go ahead and I'm going to number all the nodes in our graph here. Okay, so I will just go 1, 2, 3, 4, 5, 6, 7, 8. And I'm just doing that because it's easier for me to reference them rather than writing out Nebraska on all my variables or whatever. Yes?
Are the 3 in the middle like processing plants at all?
Yeah, you might call, they might be storage facilities.
Because if it's just storage, wouldn't it be easier to just deliver it straight to like the retail?
Maybe, but it depends upon your network. Again, if you think to the example of Walmart, none of their vendors ever go directly to the retailer, right?
Yeah.
What they do is they go to here, they bring all their supply to this location, and then they divvy it out to all their retail facilities.
Is it like cheaper for them to do it themselves?
It's not necessarily cheaper, but it allows you to do efficiency, right? Because if the vendor, if you think about if you were a vendor for Walmart, you wouldn't want to send a semi to every single Walmart store in the nation where you drop off 5 of a product here and 7 of a product there and 15 of a product here. It'd be a really inefficient delivery mechanism.
Okay.
If they can send, a whole pallet of stuff to a Walmart distribution center, and that Walmart split that up, and then Walmart doesn't just bring your product, and if you're thinking about this from a vendor's perspective, to your final retail, but they bring a bunch of different vendors.
Okay.
So they split up a little bit of paper and a little bit of sporting goods and a little bit of clothing and a little bit of food, right? And together that's enough to fill up a semi truck
Right, okay.
to go to that. And so that makes it more efficient because then the vendor's just bringing one large shipment to one place rather than a bunch of tiny little shipments to a bunch of places.
Right, okay.
Okay? So, and then this, of course, is a simplified thing, so you can
Right.
do it on the
It's
board.
like
But if
one
you think
product,
about
sure.
it in the scale of a Walmart or an Amazon, we don't just have 3 final destinations, we have hundreds or
Right.
thousands. Right? In Amazon, this is your home,
Yeah.
right? In Walmart, these are the different retail facilities. Right? So we're talking really large numbers of these.
Okay.
in either of those cases. So this is just to make it tractable.
Okay.
Okay? And we're still going to use that same notation that we used on Monday, or Wednesday, sorry, where when we say x sub ij, what we're saying is going from location I to j. So we would have x13 represents this route right here from Nebraska to Kansas City. And x47 represents from Omaha to St. Louis right here. Okay? And so we are going to, just like we did on Wednesday, we are going to have supply constraints. And we are still going to have demand constraints. Those aren't going to be any different than we did before. So help me out. Let's start with the supply constraints. What do you expect the supply constraints to be for, let's say, Nebraska? What needs to be true for Nebraska? What's less than or equal to 300?
The amount, the outflow.
Okay, so how do we compute what that outflow is?
So 1, 3 plus 1, 4 plus 1, 5.
Okay, I'll do it equal now. It's 300, right? Because we have 300 in Nebraska.
Okay.
Okay, what's going to be the supply constraint for Colorado? It's going to be 2, 3, 2, 4, and 2, 5, right? Because the 2 represents the Colorado, the 1 represents the Nebraska here. And this will also equal 300 because we have 300 units available at that location right there. How about the demand? What's the demand constraint going to be for Chicago? Say that louder, you were right.
It'd be 364656 is equal to 200.
Right? Because that represents all the stuff that's coming in to the Chicago location. We see that by having the 6 as the last subscript here.
Okay. Am I-
All right, how about St. Louis?
374757.
And that has to be 100. And then Cincinnati, 38, 48, and 58 is 300, right? All right, so up till right now, this doesn't look anything different to what we've already done. But clearly, there's something different about this. So we need to be able to represent something different about these middle warehouses that are different from the producers or the consumers. Okay? And that's what's new about the transshipment that's different from the transportation problems. So what needs to be true about Kansas City? In the end, how much stuff do we want in Kansas City? We want 0, okay? The technical term for this is that the inflow is equal to, I'll put little arrows on here, is equal to the outflow. Right? As much stuff as comes into Kansas City better be sent out of Kansas City. We don't want to keep any stuff left behind. So how do we represent this? How do we represent what's coming into Kansas City? Yeah.
So that's 1, 3 plus 1, 4 plus 1, 5.
1, 3
Sorry.
plus
2, 3.
2, 3. That's what's coming into Kansas City. And what we're saying is that has to equal what's going out of Kansas City.
3, 6, 3, 7,
3, 6, 3, 7, and 3, 8. Okay? Before I do the next one, let's do the next one. Omaha. What's coming into Omaha?
Same thing.
1, 4, and 2, 4, right? And what's going out of Omaha? 4, 6,
4, 7, 4, 8.
4, 7, and 4, 8. And then finally, what is going into Des Moines?
1, 5, 2, 5. 5, 6, 5.
And what's going out of Des Moines?
5, 6, 5, 7,
5, 6, 5, 7, and 5, 8. Okay? Now normally, what did we say is true about the right-hand sides of our constraints? Constant. So we need to transform these equations to get a constant on the right-hand side and get our variables on the left-hand side. So how do we change this first constraint so that the variables are all on the left-hand side?
Subtract the ones on the
We just simply subtract the right-hand side, which is nice because now it's really easy to see what's an inflow and what's an outflow, because an inflow is positive and an outflow is negative. Okay, and then we do the same transformation for these other two constraints. Right? We would do x14 plus x24 minus x46 minus x47 minus x48 needs to be 0, and x15 plus x25 minus x56 minus x57 minus x58 equals 0. All right? So now we have our supply constraints, we have our demand constraints, and then these are what you might call our equal flow constraints. In other words, everything that comes into that system has to go back out of that system right there. All right? Questions about our setup, what we're doing mathematically. Okay? Let's see how we set this up on the computer. Can you help me out with the lights again? Okay, this is what I have from Wednesday. I'm just picking up where we left off. Okay, what I'm going to do is I am going to have another set of columns. One set of columns, you know what, I'm going to do like this. There we go. One set of columns right here represented sending it from those distribution centers to the final locations. So I'm going to do the same kind of thing over here, but representing going from the farmer to the distribution centers. Okay, same exact kind of setup as we had before. So we're going to have Nebraska and Colorado, and we're going to have Kansas City Omaha, and Des Moines. And I'm going to go ahead and I'm going to copy those. Here. Because we're going to have shipping costs for those as well. So let's fill those out. First, we know my notes here. Nebraska, Kansas City, 16, 10 and 12, 15, 14, and 17. So those are just these costs right here. And then we could do the same thing here. We're going to have a local demand. All right, let's label it better. Inflow and receive. We'll call this supply here. Ship. And we're going to do the same thing. The amount that Nebraska had, we said, was 300, and Colorado has is 300. Our shipped is really easy. It's just that sum of this row right here. And our received is really easy. It's that sum of that column. All right? But inflow, but we don't have this kind of demand like we did before, right? In fact, let me go ahead. Find it now. There's this supply right here should be what is received, right? So it's not going to be a fixed number right here. So let's do this as outflow. There you go, you can see everything. Let's take that out. All right. So let's see if we can get this. We need to update our shipping costs, right? What are our shipping costs now? How much does it cost to ship stuff?
Some product of those.
Which do the some product?
Yeah, there over to D, and then same thing for.
Is that everything it costs to ship it? No, what else?
We need the two that we have.
Right, we need both parts of the shipping. All right. So we count how much it costs to ship stuff from our farmers to our distribution centers by multiplying these values together. And we count how much it costs to ship from our distribution centers to our final manufacturers by multiplying these values together right here. And then we have to add both of those together to get our total cost. Okay? So let's look at our model here then. Our objective cell is not going to change because I kept it in the same cell. But our variables are definitely going to change here, right? They're going to be both how much we send from the farmers to the distribution centers, as well as how much I send from the distribution centers on to the, excuse me, to the manufacturing facilities. So now I've got two sets of variables. And I'm just going to delete these constraints to start over fresh here. All right? So let's do our constraints in order. Let's do our supply constraints first. All right? Our supply constraints are right here, right? That the amount that we ship needs to equal what we have at those different facilities. Right? Does everyone see that? The amount that we end up shipping from each one of these places has to equal the amount that we have at those locations. And we can do our demand constraints next. So again, the amount that we receive, I'm just going to call this receive, needs to be equal to the amount that we actually want. Let me just update that label real quick. There we go. So we've got our first two types of constraints. We've got our supply constraints and we have our demand constraints. Now we want these equal flow constraints right here. So let's do that one at a time just to make it easy. This is the amount that Kansas City receives, right? We want to make sure that that's equal to the amount that Kansas City ships out. And we can do that for each town. The amount that Omaha has needs to be, so so I can highlight everything that comes in to those distribution centers and make sure it's equal to everything that's shipped out of those distribution centers. All right, so if we see our model now, we've got our variables here, how much gets shipped out of the farms, how much gets shipped out of the distribution centers. We make sure that we receive everything that we wanted. We make sure that we ship out everything that we have, and that the distribution centers ship everything that they receive. That those two values are the same as each other, while minimizing our total shipping costs right here. All right. Questions before I saw it? Yeah.
What was the formula for the shipping cost again?
The formula for the shipping cost is a sum product of these two matrices added to the sum product of these two matrices, because we want to know the cost at this level plus the cost at this level right here. All right. Yes.
Could you pull up the model just one more time? The open silver model.
So we've got our objective cell is our shipping costs that we want to minimize. Our variables are what gets shipped out of the farms to the distribution centers, and then from those distribution centers on to the manufacturing units. And then finally, we've got our three types of constraints. Our first constraint is our supply constraint. Our second constraint is our demand constraint, and our third constraint is the equal flow through the distribution center. equal, right? 300 plus 300 is equal to...
Is it because the
Oh,
right hand side isn't a
Yeah, that's
constant?
not, it's not equal. We had updated that at the very end of the class. To make it was impossible to solve, because that was a 250, so I was trying to send out 600, but I wanted 650, and so I couldn't come up with a solution. There we go. Data matters. Right, so a shipping cost of 12,400. All right. Yes.
So does that mean you could just close down the Kansas City one since it's not receiving or shipping out anything?
Yeah, in this example, yeah,
Okay.
we're not shipping to Kansas City.
So if you changed like the supply and demand, then would that change like? would that change that? Or would it stay?
It probably would not, because what's going on is the cost to ship via Kansas City from each of these is too high, right? So if we take from Nebraska to Chicago through Kansas City, it's going to cost us 22. But if we look through Omaha, it's only 17.
Mm-hmm.
And if we look through Des Moines, it's 21. So Kansas City is always more expensive than these two.
Oh, okay.
And you can do that same analysis for St. Louis and Cincinnati,
Right.
and you'll see that it's too costly to go through Kansas City. So the only reason why you would go through Kansas City is if you had an even more robust model that says we can only handle a certain amount of product through our facility at any given time.
Okay.
Right, and then you would put that in something like here, and that would be a constraint that would say that the inflow can't be larger than a
Right.
certain amount.
Okay.
And that would represent maybe the facility size that you have it.
Right.
And you can only handle so many semi-trucks or so many train cars at that facility at any given time.
Okay.
Okay, so we can continue to make this more and more robust
Right.
representation of what the situation is. All right. So models are only so good. They answer problems that in the abstract, but where they really become valuable is when you start to analyze what if scenarios. What happens if something changes? So for instance, what would happen, for instance, if this route right here, say between Nebraska and Des Moines, let's say there was a big snowstorm and the interstate got closed down. You know, what would be the best way to reroute things? Okay, how would we represent that in this model? So we want to represent that we can't send stuff via Nebraska to Des Moines.
Set a constraint that says that variable has to be 0.
Okay, so that's one possible way to do it, is add another constraint. What's another way that you can do it? Yeah.
You can just remove it from the supply constraint. Like Nebraska doesn't have like 1 to 5 or whatever.
Yeah. So you could eliminate this, but then it's going to make in this spreadsheet it's going to make it non-square, right? Because we would have these 5, and it's going to make it actually harder to do in our spreadsheet.
You could set the price for the Nebraska to Des Moines trip to be like $1,000.
Right. We could make this absurdly high, right? And we can resolve it. And notice that it's just going to automatically route around Des Moines. right? So you got two possibilities there. You can put a constraint to make that 0, or you can just do this. And I'm pointing this out because we're actually going to take advantage of this in our next kinds of problems. Okay? That putting a large number here represents what you were talking about, Nathan. It effectively erases that connection. Because it's so costly, there's no way you would never, that you would ever go across that route. So it's effectively the same thing as not having a route at all. Okay. And the reason why we want to do that is because with our notation, something like x 1 8 is technically possible, right? Because that notation makes perfect sense. It doesn't make sense given our problem statement because we don't have a connection between Nebraska and Cincinnati here, but our notation does. And we're going to actually construct these problems to be a little bit more generic here in a second. And we want to be able to represent a connection between places and a non-connection between places. It will actually make it easier to construct these in our spreadsheets even more rapidly. All right. So let's just add a last little wrinkle here. And we'll talk about it, but we probably won't get a chance to solve it. So what happens if we have an express route between Colorado and St. Louis? Okay, and that route costs us only $13 a unit, but we have a limitation. So this limitation has to be less than or equal to 40. That we can only ship 40 units on that route. We've got some special deal with freight, and that's as much trucks as they have available to go from Colorado to St. Louis. Okay. How do we do that with this? Because we have no way to go from Colorado to St. Louis. There's no connection here. Okay. Hopefully you can see we can easily add this route to our supply constraint. And we can add this route to our demand constraint. It doesn't affect these constraints at all. We would have to add one extra constraint to handle this route, this specific route being less than 40. It would just be a standalone constraint just for that. Okay. But how do we do it in a nice general purpose way like we have on our spreadsheet here? Okay, any ideas? How we might try to make it more generalized?
You have to make a whole new table,
Yeah, that's what we want to try
or
to
just make like a
avoid.
bigger table.
Yeah, we do need to make a bigger table. But we want to avoid making another set of tables, right? It's going to get more and more complicated. So the answer that is, we're going to treat St. Louis as if it's kind of got a virtual distribution center here.
So we're just like,
And so you can go from Colorado to St. Louis, right here. So we will add St. Louis in here, right here. And we'll also have to add St. Louis down here. And what we'll do is we'll just make the costs from going to Nebraska to St. Louis really high, right? It'll be like this infinite, right? We'll basically not have a connection there. And then when we add St. Louis over here, we'll make sure that St. Louis can't send to Chicago or Cincinnati. And what should we make the costs from going to St. Louis to St. Louis? It's 0, right? So you can just kind of virtually slide it from the warehousing side to the actual manufacturing side at no cost. Okay, we'll see that on Monday. Have a great weekend, everyone.